This is for Year 12 Specialists. It comes out of the 2019 Exam 2 question number 1e. Remembering that the early part of the question we have this parametric equation that's the same as this, and in part D we had to sketch this from there to there, and I've done that using my calculator that I've opened up my graphing window, and there it is there. I drew it given my restriction. Where was my restriction? There's my restriction, drag and drop with restriction, and it draws it just for me, and that gives me the y coordinate there. Okay, part E, a portion of the graph is rotated about the y-axis to form a solid of revolution. Write down, but do not evaluate the definite integral in terms of t. Okay, so not in terms of x and y. If it was in terms of y, the volume's going to be pi, the integral from the lowest y value, which is 0, to the highest, which is 2 root 2 of x squared dy. And if I put this on my calculator and I solve that for x, I get these two expressions. And since if I swap x's and y, it's the same as doing the inverse, so I want the positive square root. So I want, what was that again? That is this one. So x equals the square root of 1 plus y squared plus 1. Is that correct? Which means x squared equals 1 plus y squared square root plus 1. Okay, so I've now got volume equals pi from 0 to 2 root 2 of 1 plus y squared square root plus 1 squared dy. That's what it would be in terms of y. I need to do it in terms of x. So I'm going to come up to this parametric equation, and y squared is tan squared, so y equals the tan of t, therefore y squared equals the tan squared of t. So what I'm going to do is I'm going to replace everything in here about y, but do it with respect to t. dy dt equals sec squared of t, which means that dy equals sec squared of t dt. So I will replace dy with this in that position. I will replace y squared with that in that position. When y equals 0, then, when y equals 0, tan of t equals 0, so therefore t equals the inverse tan of 0, which is 0. And when y equals 2 root 2, the tan of t equals 2 root 2, which means t is the inverse tan of 2 root 2. So this is going to become v equals pi, the integral 0 becomes 0, 2 root 2 becomes the inverse tan of 2 root 2, bracket, squared, the square root of 1 plus tan squared t plus 1, dy is sec squared t dt, and 1 plus tan squared is sec squared, plus 1, which is sec t plus 1, squared times sec squared t dt, integral pi from 0 to the inverse tan of 2 root 2 should equal v in terms of t instead.